In this section, we're going to talk about taking monomials to a power. Powers of monomials. Let's start by writing the monomial a to the third power, and we're going to raise it to the fourth power. The result, a to the third to the fourth, is called a power of a power. Now you can simplify it like this. We're taking a to the third times itself 4 times. Now, if you use the rule from yesterday, it says, since we have the same base, we're just going to add all the powers, and that would give us a to the 12th. But there's a shortcut. What do you notice to go from a to the third to the fourth to a to the 12th? Well, we can just multiply the powers, 3 and 4. So that is your key idea. Your key idea, your rule, is this. B to the m to the n is going to be equal to b to the m times n. You just multiply the two powers together. So for some quick examples, number 1, c squared to the 5th. 2 times 5, it would give you c to the 10th. Y to the 3rd to the 10th. 3 times 10, y to the 30th. Number 3, x to the 1st to the 3rd would just give you x to the 3rd. Obviously, those are the easy ones. But now, let's say we have a product of 2x. And we're going to raise 2x to the power of 3. The result is 2x to the third power. It's called the power of a product, because we're taking the product of 2 and x and we're raising that to a power. Now you can simplify it as 2x times 2x times 2x. But you have 2 different things that you are taking to the third power. You have to take the 2 to the third power and the x to the third power. So you have to take 2 to the third power and the x to the third power. So it's going to look something like this. 2 to the power of 3 times x to the power of 3. 2 to the power of 3 is just 8, and then x to the third is just that. So everything that's inside the parentheses, you have to take to that power. So let's try another example. Number 5. Negative 4c to the power of 3. Well, we're going to take negative 4 to the third power. Well, here's what I do. This is what my personal opinion is. I just look at the negative. A negative to an odd power is going to give me negative. 4 to the third power is going to give me 64. And this is a 1, so 1 times 3 is just c to the third. My answer is negative 64, c to the third power. Number 6, negative xy squared to the 4th. I now have 3 things that I'm taking to the 4th power. A negative 1, or a negative, an x, and a y. So a negative to an even power is positive. X, that's to the 1st, so 1 times 4 gives me x to the 4th. 2 times 4 gives me y to the 8th. So my answer would be x to the 4th, y to the 8th. Number 7. Negative 2, a to the 4th, b to the 6th, all to the 5th. Negative to an odd power is negative. 2 to the 5th power. Well, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And now you just multiply the powers. 4 times 5 is 20. 6 times 5 is 30. So my answer is negative 32, a to the 20th, b to the 30th. Now we have to review order of operations, because you have to still use order of operations when simplifying an expression. Here, we have negative 4x times 5x cubed squared. Order of operations states that we have to do powers before multiplication. So you have to take negative 4x times whatever 5x to the third squared is. So that would give me negative 4x times 5 squared is 25, and 3 times 2 would be x to the sixth. Negative 4 times 25 gives me negative 100, and then x times x to the seventh. Now this is from yesterday. Same base, add the powers. So my answer would be negative 100 x to the seventh. Number 9, negative y squared times 4y to the seventh squared. We have to first do this, the exponent of 2. So the negative y squared comes down. 4 to the second power gives you 16. Y to the seventh to the second, 7 times 2 is the 14th. Negative times 16 is negative 16. Y squared times y to the 14th is y to the 16th. So my answer is negative 16, y to the 16th. We're going to do one more. We're going to solve an equation. X to the fourth to the 2a minus 3 power equals x to the fourth. Here's what the directions state. For each equation, find the value of a that makes this true. So I have to find the value of a. All you have to do is use the same rules in order to write an equation. Right here. Power to a power, I multiply them. That gives me x to the 8a minus 12. All I do is take 4 times 2a and 4 times negative 3. I'm distributing a 4. Equals x to the fourth. Well, what do I know? I know this power has to equal that power. So I can just drop my x's. My equation is this. 8a minus 12 equals 4. I add 12. That gives me AA equals 16. Therefore, a equals the value of 2. So please remember, the rule for this chapter states, anything, if you have one base taken to a power to another power, you just multiply your two powers together.